Okay, we're going to take a look at our last two examples for our curved mirrors. And this top one, I'm still looking at a concave mirror, but this time I'm placing the object in front of the focal point. And this is going to be an example of if you look in a makeup mirror or a shaving mirror. All right, so the first ray I'm going to do is going to be parallel to the principal axis. It hits the mirror, it bounces through the focal point like so. So this is in fact what the light is going to do. That's really ugly, but I'm sorry. All right, second ray I'm going to have to do is going to be through the center of curvature once again. Oh, geez. All right, so what's going to happen is the light actually hits the mirror, bounces back on top of itself like so. So the arrows are showing you in reality what the light is doing. So the light is diverging on the back side, or the front side, I suppose, of the mirror. And so they're never going to converge on the left-hand side, which means where they actually will cross is going to be inside the mirror. Now, once you go inside the mirror, we call that a virtual image. You cannot produce this on a screen. You cannot project this on a screen. And so now, look at for the first time what's happening here. My lines are crossing above the principal axis, and I've got an image inside the mirror. So that's why you're going to see your face in a makeup mirror quite large. And that's what's going on here with a concave mirror. Now let's go ahead and describe this thing. This is not real light. This would be called a virtual image. This is upright, and it's bigger, so it's enlarged. So now let's do the math with this, because I want you to notice a pattern that's going on. And so now this time we're going to use our mirror equation, so 1 over 25. And let's say that our object distance was 20 centimeters. It's closer to the mirror than the focal point. And now we're going to calculate DI. So in my calculator, I'm going to put in 25, x to the minus 1, minus 20, x to the minus 1, or 1 over x. That gives me negative 0.01, but I need to remember to hit the 1 over x button again. And when I do this, DI equals negative 100. And for the first time, look at what's showing up in front of my answer, in front of my solution, a negative sign. And that's what's going to happen every time you have a virtual image. The negative sign will show up. Now let's go ahead and calculate the magnification. So the magnification is going to equal the negative times DI, which is negative 100, divided by the object distance, which we said was 20. So according to this, this should be 5 times greater. Patterns are important in physics. So if you notice that when it was a real image, they were always upside down. When it's a virtual image, it's going to be right side up. When it's a real image, your DI will be positive. When it's a virtual image, your DI will be negative. All right, and the very last case that we're going to take is the convex mirror. Now the nice thing about the convex mirror is there's only one ray diagram, no matter where you place the object. So I'm going to do my parallel ray that hits the mirror, but since it's a diverging mirror, essentially, what's going to happen, instead of the rays focusing on the left, it's actually going to diverge and spread apart. But what it's going to do is go in here through the focal point like so. All right, so it's going to actually come in like this, hit the mirror, and diverge. I also am going to need the center of curvature, because the center of curvature, the angle of incidence is going to be 0. That means the angle of reflection is going to be 0. All right, here we go. So I'm going to go from the top there. Now, as soon as I go inside the mirror, this should be my center of curvature. As soon as I go inside the mirror, that's going to make it a virtual image. So the rays would actually cross in here like so. And if I were to ask you to describe it, the rays cross inside the mirror, that makes it virtual. They cross above the principal axis. That makes it upright. But look at the size of the arrow of the image. And you can see that it's smaller, so we're going to call that diminished. Now when you calculate your DI, when you do this, my focal length is going to be negative because it's a negative mirror. So let's say it was negative 1/25 equals, and let's say this is 40 centimeters. It could be any number. And what's going to happen is no matter what you do, you're going to get a negative image distance, no matter what your F is, no matter what your object distance is. So I throw that in my calculator, and let's see what I get. And I get negative 15.4. Negative 15.4 centimeters. And that just gives you an idea of how to do mirrors. Good luck.